how do you select the right AI model for a specific problem? So you've got a problem and you're wondering which AI model should I use? Picking the right model isn't magic, but it is a mix of science, experience, and asking the right set of questions. Think of it like picking a vehicle, right? So if you're going off-roading, you want a Jeep. If you're racing, perhaps a sports car. And if you're hauling stuff, maybe grab a truck. And so AI models are somewhat similar in that they're not all the same, just like vehicles. They're built for different jobs. So here's how to break it down. Step one, you've got to ask the question, what type of problems you're solving. If you're predicting a number, that's regression. So now you're using models like linear regression, random forests, or perhaps even neural networks. If you're picking a category, that's classification. So you go with logistic regression, you go with SVMs, or deep learning if you've got a lot of data to go through. If you're labeling pixels in an image, then you're in sort of the computer vision world. Think about CNNs, convolutional neural networks, or transformers like VIT. If you're working with text, that's natural language processing, NLP. You'll certainly want RNNs, LSTMs, or even better transformers like BERT or GPT. If the task at hand is planning or decision making, that's reinforcement learning. Think about Q-learning or policy gradient methods. Now, once you've gone through that process, you go through what we call the second step, and that is trying to understand how much data do you have. If you have small data sets, then go for simpler models like decision trees or logistic regression. If you've got lots of data, now you can certainly unleash deep learning or transformer-based models. If the data is not labeled, then you might need unsupervised learning like clustering or dimensionality reduction. These are PCAs or TSNEs. The third step is, do you need speed, accuracy, or explainability? Now, if it needs to run fast, then go small, shallow models or tiny machine learning models. Now, if you need transparency, models like decision trees or linear regression are certainly explainable. But if you want pure performance and don't mind a black box, that's where deep learning and ensemble methods like XGBoost really do well. Then the fourth step is where you start asking the questions, are there any special constraints I need to be worried about? So for example, I've got limited compute. In that case, you certainly want to avoid the big neural networks and try more lightweight models. Is this a regulated domain like healthcare, which will require explainability and perhaps even robustness? Do I need to respond real time? So latency now matters. So I want to keep it lightweight. So choosing a model isn't just what's the best. It's what's the best for this particular situation, just like you would when using a race car for driving fast and not necessarily to move furniture. You, in the same breath, would not use a giant neural network to solve a problem with only perhaps 200 rows of data. So it's important to try a few, compare performance, and always start simple before going into the deep end of complexity. That's how you pick the right AI model. It's part science, it's part strategy, and a little bit of vibe checking with your data.